August 15th, 1977. A radio telescope in Ohio points at the stars. It's listening for nothing in particular. For 72 seconds, it hears something it was never supposed to hear. Then it stops. Forever. The telescope is called Big Ear. It's the size of 3 football fields. Its job is simple. Scan the sky, log the noise, move on. Most nights it hears static, cosmic radiation, background hum, nothing alive in it. But this night is different. A signal spikes in at 1420 megahertz. That number matters. It's the exact frequency hydrogen emits in space. Scientists call it the Waterhole, the one quiet channel where any civilization anywhere would think to broadcast, because it's the frequency every species with a radio telescope would eventually find. If you wanted to be heard across the galaxy, this is the channel you'd choose. And something chose it. 3 days later, a volunteer named Jerry Ehman is reviewing the printout. Rows of numbers, mostly single digits. Background noise. Then he sees it. 6EQUJ5. A signal 30 times stronger than deep space background. Ehman grabs a red pen. He circles it. He writes one word in the margin. Wow. That word becomes the name of the most famous unexplained signal in the history of radio astronomy. But here's what most people get wrong about that night. It wasn't just strong, it was shaped correctly. The signal rose and fell exactly the way it should if it came from deep space, not from Earth. Which means whatever sent it wasn't sending from here. So they looked for it again. Ehman himself re-pointed telescopes at the same coordinates. Nothing. In 1987, a full 10 years later, another team tried. Still nothing. In 1995, using more advanced equipment, they tried one more time. Silence. Over the following decades, radio telescopes have scanned that patch of sky more than 100 times. Not once has the signal repeated, which raises an uncomfortable question. If it was a satellite, why did it never come back? If it was a comet, a theory floated in 2017, why don't comets in that region produce it today? If it was human interference, why has no other instrument on Earth ever picked up that exact frequency shape, before or since? Every explanation solves one detail. None of them solve all 3. Here's where it gets stranger. The coordinates the signal came from sit near a cluster of stars in Sagittarius. One of them, Tau Sagittarii, is roughly 120 light-years away. That means if something out there sent this on purpose, it was sent before Big Ear even existed, before radio astronomy existed. The message, if it was a message, left its origin around 1857. It crossed a century of human history in silence, world wars, moon landings, the invention of the internet, and it arrived at the exact moment on the exact frequency that one telescope in Ohio happened to be listening for 72 seconds. Then, never again. In 2020, a team of astronomers proposed a new candidate. A cloud of cold hydrogen gas, disturbed by a passing comet, could theoretically produce a burst like this. It sounded promising, until the maps came out. The comet in question wasn't even in that part of the sky on the night in question. The theory collapsed within a year of being published, which means, as of now, in 2026, the leading scientific explanation for the most famous signal from space is that we don't have one. Not officially, not definitively, not for almost 50 years. So what do we actually know? We know it was real. Multiple instruments confirmed the recording. We know it wasn't from Earth. Its signature matched deep space origin, not ground interference. We know it was on the one frequency a civilization would logically choose to be found on, and we know it happened exactly once. Some scientists believe it was a rare, natural cosmic event we simply haven't identified yet. Others believe Big Ear caught something intentional, a brief window into a transmission never meant to reach us, or meant to reach us only once. Neither camp can rule the other out. That's the part that keeps astronomers awake. Not that something happened, but that we had one chance to understand it, and we let it pass without a second listen. We spend so much time asking if we're alone, but the wow signal asks a colder question. What if we're not, and the moment we might have finally known happened once, lasted 72 seconds, and we simply weren't ready to catch it twice?